Hello everyone, welcome back to another show. This time I'll be doing application of derivatives of 2024 JEE main of January shift. Very less number of questions are asked from this topic in 2024 January shift. Only 6 questions. Okay, so we'll discuss the questions one by one, and the number of questions asked from various topics: increasing and decreasing functions 3 questions, maxima, minima, local maxima, local minima 2 questions, and miscellaneous 1 question. Altogether they have only 6 questions. Compared to April shift of 2024, January shift they have only asked 6 questions from this topic. We'll discuss the questions one by one along with the concepts. Okay, given the function f of 5 times f of x plus 4 times f of 1 by x equal to x square minus 2. For all x not equal to 0, y is given like this: 9x square f of x. Y is strictly increasing in which interval you have to find out. Okay, so given functional equation, this is we are very familiar of finding the function f of x using this functional equation. Okay, what is given is the functional equation. From the given equation you need to find f of x. After finding f of x you have to substitute here, and you have to find in which interval the function is strictly increasing. So quite common question, typical JEE level question. So what I'll do is I'll replace x by 1 by x. My aim is to find f of x first. So to find f of x, what I'm doing is I'm replacing x by 1 by x. Replace x by 1 by x. The given equation is 5 into f of x, given 5 into f of x plus 4 into f of 1 by x is equal to x square minus 2. This is equation 1. Replace x by 1 by x. Replace x by 1 by x. What we get? When we replace x by 1 by x, we are going to get 5 into f of 1 by x. Wherever x is, it becomes 1 by x, plus 4 into f of x is equal to 1 by x square minus 2, equation 2. Replacing x by 1 by x. My aim is to find f of x. To find f of x, I'll eliminate f of 1 by x. To eliminate f of 1 by x, to make the coefficient of f of 1 by x same. So for that I'll multiply the first equation by, you multiply by 5. Okay. Second equation you multiply by 4. So that 5 into 4 is 20. Here also 5 into 4 is 20. So this becomes 25 f of x. Subtract the two equations. After multiplying the first equation by 5 and second equation by 4, then subtract. What we get? I am getting 25 f of x. Here I am getting 16 f of x. 25 f of x minus 16 f of x will give 9 f of x. Equation 1 into 5. Equation 1 into 5 minus equation 2 into 4 will give 9 f of x. Correct? 25 f of x minus 16 f of x. That is 9 f of x is equal to f of 1 by x term will cancel. 4 into 5 is 20. 5 into 4 is 20. 20 f of 1 by x will cancel. What we get is 5x square minus 10. Correct? Multiply by 5 here. Minus 4 by x square. Minus of minus 8 becomes plus 8. Like this I get. You can divide the entire equation by 9 here. I want to find y is equal to 9x square f of x. Now we multiply by x square here from this. Therefore y is equal to 9x square into f of x. 9 f of x we have. You multiply by x square. You get 9x square f of x. Okay. 9 f of x we have. No. You multiply by x square to get 9 f of x square f of x. 5x power 4. Minus 10 plus 8 is minus 2. So minus 2x square. Correct. Minus 4 by x square and x square becomes minus 4. You are multiplying by x square and writing. Correct. Multiply by x square. Multiply by x square. Minus 10 plus 8 is minus 2. Minus 4 by x square and x square. Minus 4. Differentiate this. I got the function y as 9x square f of x. This is my 9x square f of x. Now differentiate this. dy by dx. dy by dx is how much? Derivative of 5x power 4 is 20x cube. Derivative of 2x square is 4x. Derivative of 4 is 0. Here you can take 4x common. 5x square minus 1. Correct? You can write this as 4x into, you can divide by 5. or equate it to 0 to get the critical points. If you divide by, you can factorize it as root 5x minus 1 into root 5x plus 1, correct? Root 5x minus 1 into root 5x plus 1. If you equate this to 0 to get the critical points, 4 can't be 0. X equal to 0 is one critical point. X equal to plus or minus 1 by root 5, correct? So you want to find in which interval the function is strictly increasing. We use Wavy-Cobb method. Mark the critical points. Critical points are 0 plus or minus 1 by root 5. Minus 1 by root 5 is here. 0 is here. 1 by root 5 is here. Right side of 1 by root 5 start by extreme right. Coefficient of x cube is positive here. Correct? X into x and x. Coefficient of x cube is positive. Right side of 1 by root 5 will be positive. 1 by root 5 is derived from where? 1 by root 5 is got from this. Its power is 1. Odd number. So sign changes. Becomes negative. 0 is got from where? 0 is got from this. X. X power 1. Power of x odd number. Again sign changes. Becomes plus. Minus 1 by root 5 is derived from where? From this. Correct? Minus 1 by root 5 is got from this expression. What is the power of this? 1. Odd number. Odd number means again the sign changes. Becomes minus. Okay. So where the function is strictly increasing, you have to find out. Derivative should be positive. Derivative is positive in the interval minus 1 by root 5 to 0 and 1 by root 5 to infinity. So here and here the function is decreasing here. Here the function is increasing. Here the function is decreasing. Here the function is increasing. Therefore y is strictly increasing in the interval. Y is strictly increasing in the interval. Strictly increasing in the interval. Where derivative is positive, there the function is strictly increasing. Minus 1 by root 5 to 0 union 1 by root 5 to infinity. Function is strictly increasing in the interval. Minus 1 by root 5 to 0 union 1 by root 5 to infinity, which is option B. Finding using Wavy-Cobb method, I am determining the sign scheme where derivative is positive, where derivative is negative. Please learn this Wavy-Cobb method, quite useful. Even in maxima, minima, there are some questions. There also we can apply this Wavy-Cobb method to find where the function is having point of maxima, point of minima, derivative sign changes or not, all those things. Even an increasing and decreasing function is quite useful. Okay. So extreme right side we start positive because coefficient of x cube is positive. Then alternate plus minus because all the powers of x and whatever linear factors are there. No, all are linear factors. The power of the variable is 1 there. So odd number means sign changes accordingly. I wrote. Move on to the next one. Question number 2. Given g of x equal to 3 into f of x by 3 plus f of 3 minus x. And second derivative is positive for all x belongs to the interval 0 to 3. G is decreasing in the interval 0 to alpha and increasing the interval alpha to 3. You have to find 8 alpha is equal to how much? 8 alpha is equal to how much? G of x given like this. G of x is equal to 3 times f of x by 3 plus f of 3 minus x. Differentiate this. What we get? G dash of x. G dash of x is constant into variable. Constant key values. Derivative of f is f dash. F dash of x by 3 into derivative of x by 3 is 1 by 3. Derivative of f of 3 minus x. F dash of 3 minus x into derivative of 3 minus x is minus 1. 3 cancels. What we get is f dash of x by 3 plus into minus minus f dash of 3 minus x. I'm getting g dash of x like this. Correct? Constant into variable. Constant key values. Derivative of f is f dash. F dash of x by 3. Derivative of x by 3 is 1 by 3. Derivative of f of 3 minus x. F dash of 3 minus x into derivative of 3 minus x minus 1. By chain rule it follows. And I want to find g is decreasing in the interval 0 to alpha, increasing in the interval alpha to 3. So now you take g dash of x less than 0 because g is decreasing. Given g is decreasing, as g is decreasing, implies g dash of x is less than 0. G dash of x is less than 0. G dash of x is here. F dash of x by 3 minus f dash of 3 minus x. F dash of x by 3 minus f dash of 3 minus x is less than 0. G dash of x is less than 0. So f dash of x by 3 minus f dash of 3 minus x less than 0. That means f dash of x by 3 is going to be less than f dash of 3 minus x. What about the nature of f dash you see? Because it told second derivative of f is positive. Yeah, second derivative is positive means first derivative should be increasing function. Given f double dash of x positive, given f double dash of x is positive, f double dash of x is positive implies f dash of x is increasing. F dash of x is strictly increasing again, right? Apply the definition of strictly increasing function. Function is strictly increasing means what? As x value increases, f of x value increases. If f dash of x is strictly increasing, I can conclude that f dash of x by 3 is less than f dash of 3 minus x. From this, x by 3 is going to be less than 3 minus x. Because the function f dash is strictly increasing, if you remove f dash, inequality remains the same. So from this, if you solve, x by 3 plus x becomes 4x by 3. Correct? 4x by 3 is less than 3. So x is less than 9 by 4. X is less than 9 by 4. Therefore, less than 9 by 4 means it should be greater than 0 because they told x belongs to the interval 0 to 3. Domain of the function is only in the interval 0 to 3. Therefore, I can conclude that the function g is decreasing in the interval 0 to 9 by 4. Therefore, the function g is decreasing in the interval 0 to 9 by 4. Same way we can apply definition of now I can consider g is increasing now. Same way I can consider g is increasing. If g is increasing, what happens? G dash of x greater than 0. Now if g is increasing, now g is increasing it. G is increasing means g dash of x is greater than 0. G dash of x is greater than 0. What is g dash of x? We got f dash of x by 3 minus f dash of 3 minus x. F dash of x by 3 minus f dash of 3 minus x is greater than 0. That means f dash of x by 3 is greater than f dash of 3 minus x. That means what? X by 3 is greater than 3 minus x. Because of second derivative is positive. Same sentence, second derivative is positive, so f dash is increasing. F dash increasing means if you remove f dash, the inequality remains the same. So if you solve this, I'll get x by 3 plus x, 4x by 3 is greater than 3. I'll get x is greater than 9 by 4, correct? From this, I'll get x as greater than 9 by 4. Greater than 9 by 4 means it should be less than 3 because the domain is in the interval 0 to 3. I can't go beyond 3. Therefore, I can conclude that g is decreasing in the interval 9 by 4 to 3. Therefore, I can write g is increasing in the interval 9 by 4 to 3. Similar type of question was asked in 2023, I think. Okay, same type of question was asked. G is increasing in the interval 9 by 4 to 3. 2023 or 2022, 1 year, same type of question was asked. So g is increasing in the interval 9 by 4 to 3. Okay. So I can compare. According to the question, g is decreasing in the interval 0 to alpha, increasing in the interval alpha to 3. Here 0 to 9 by 4 the function is decreasing. I got correct. 0 to 9 by 4 the function is decreasing, and decreasing in the interval 0 to 9 by 4. If you compare this and this, I can conclude that alpha should be equal to 9 by 4, correct? Alpha is 9 by 4. Therefore, alpha is 9 by 4. What we need to find is 8 alpha. 8 alpha is how much? 8 into 9 by 4. 4 ones are 4 twos are 9 into 2, 18 is the answer. Option C. Question asked on 27th of January, second shift, JEE Main 2024. A simple question based on increasing and decreasing. Here, important thing to be noted is second derivative of f is positive, means first derivative of f is increasing function. That is the idea here, okay? And I'm using the concept of increasing function. F dash is increasing means f dash of x1 less than f dash of x2 implies x1 less than x2, okay? That is the concept used here. F dash of x by 3 is less than f dash of 3 minus x implies x by 3 is less than 3 minus x, and solve the inequality. Same way here, g is increasing means g dash is positive. G dash is positive means f dash of x by 3 minus f dash of 3 minus x should be positive, and f dash of x by 3 is greater than f dash of 3 minus x because f dash is increasing. Why f dash increasing? Because f double dash is positive. Second derivative is positive, so first derivative is increasing. So first derivative is increasing, so I can remove the inequality, I can remove the function f dash and inequality remains the same. If it is a decreasing function, inequality is going to reverse. Here the inequality remains the same, that's the idea, okay? Question asked on 27th of January, second shift, JEE in 2024. Move on to the next one. The function f of x given like this. We have to verify which of the option is correct here. So f of x like this, 2x plus f of x is 2x plus 3 into x power 2 by 3. This implies f dash of x, derivative of 2x is 2. Constant into variable, constant key power, derivative of x power 2 by 3 is 2 by 3 into x power 2 by 3 minus 1. F dash of x, I'm getting this. Constant into variable, constant key power, this derivative of x1, 2 into 1. Here, derivative of x power n, n into x power n minus 1. Okay, so 3 cancels, so I get 2 plus 2 into x power minus 1 by 3. We can write this as 2 plus 2 divided by x power 1 by 3. Take common denominator x power 1 by 3. What I get 2 into x power 1 by 3 plus 2. This is 2 common. What I get x power 1 by 3 plus 1 divided by x power 1 by 3. F dash of x. F dash of x equal to 0 is possible when numerator is 0. And f dash of x is not defined if denominator is 0. Correct? F dash of x equal to 0 implies numerator is 0. X power 1 by 3 plus 1 equal to 0. X power 1 by 3 plus 1 equal to 0. X power 1 by 3 equal to minus 1. Cubing on both sides, we get x equal to minus 1. Real values of x as x belongs to R. And f dash of x is not defined. F dash of x is not defined for denominator equal to 0. Implies denominator equal to 0, x equal to 0. So 0 and minus 1 are the two critical points. Critical points are the points where derivative vanishes or the points where derivative is not defined. Derivative vanishes for x equal to minus 1. Numerator by denominator is 0 for numerator equal to 0. Numerator is 0 for x equal to minus 1. Denominator is 0 for x equal to 0 where the derivative is not defined. So both are give the critical points. 0 and minus 1 are the critical points. Now we can use the first derivative test to check whether it has local maxima, local minimum. Only two critical points I'm getting. You can take the number line here. Mark the critical points. Minus 1 is smaller than 0. Correct? Minus 1 first, then 0 from left side, left, right. So you can start from right side of 0. Say take a value of x greater than 0. F dash of 1 you can find out. F dash of 1 you find out. 1 power 1 by 3 is 1. 1 plus 1 2. Positive. 1 power 1 by 3 is positive. Derivative is positive for x greater than 1. Derivative is positive for x greater than 0. For x greater than 0. I am taking x equal to 1. For greater than 0, derivative is positive. If you take a value of x between minus 1 and 0, say minus half you take. Minus half for 1 by 3, it's negative. But that value lies between minus 1 and 0. Value between minus 1 and 0 plus 1 is positive. And denominator is negative. Numerator is positive, denominator is negative. So ratio becomes negative. And for x less than minus 1, say minus 2 take. Minus 2 for 1 by 3 is minus 1 point something. Minus 1 point something plus 1 is negative. Minus 2 power 1 by 3 is negative. Negative by negative is positive. So derivative sign changes from positive to negative at x equal to minus 1. So at x equal to minus 1 is a point of local maxima. Correct? X equal to minus 1 is a point of local maxima. Because derivative sign changes from positive to negative according to the first derivative test. X equal to minus 1 is point of local maxima. And at x equal to 0, derivative sign changes from negative to positive. So the derivative sign changes from negative to positive means local minima. So at x equal to 0, the function has local minima. At x equal to 0, or x equal to 0 is a point of enough. At is not required. At is not required here. X equal to 0 is point of local minima. So there is exactly one point of local maxima and exactly one point of local minima. Option C is answer. -1 is a point of local maxima because derivative sign changes from positive to negative according to the first derivative test. X equal to 0 is a point of local minima because derivative sign changes from negative to positive. So one point of local maxima and exactly one point of local minima. That is option C is answer. Question asked on 29th of January, second shift, JEE Main 2024. Move on to the next one. Question number 4. Function f of x given like this. X belongs to this interval. Want to find the nature of the function, whether it's increasing or decreasing. So apply quotient rule and find out. F of x is given like this. F of x is given to be equal to x divided by x square minus 6x minus 16. F dash of x, use quotient rule, denominator square, denominator into derivative of numerator, correct, d by dx of x minus x into d by dx of x square minus 6x minus 16. This is equal to how much? X square minus 6x minus 16. Derivative of x is 1 minus x into derivative of x square is 2x. Derivative of 6x, 6 derivative of 16 is 0. Divided by x square minus 6x minus 16. The whole square. This is equal to how much? X square minus 6x minus 16 minus 2x square minus into minus plus 6x divided by x square minus 6x minus 16. Minus 6 plus 6x will cancel. Minus 6x plus 6x will cancel. 6x. Correct? What remains? X square minus 2x square is minus x square minus 16 divided by x square minus 6x minus 16 the whole square. We can take minus and common here. Minus of x square plus 16 divided by x square minus 6x minus 16 the whole square. F dash of x. Correct? Function f of x given like this. I got f dash of x. I can see that x square plus 16 is always positive for any value of x. Except minus 2 and 8, exception is there. That is because denominator becomes 0 there. They removed the points minus 2 and 8 because those points denominator is becoming 0. So I can tell that the derivative is always less than 0. Always less than 0. Denominator is positive because square is there, except those two, leaving those 2 points minus 2 and 8. Denominator is positive, correct? And x square plus 16 also positive for every real number. So this derivative is overall negative because of this negative sign. This is f dash of x is less than 0. F dash of x is less than 0 for all x belongs to the interval all real numbers except minus 2 and 8. Minus 2 and 8. Derivative is negative for all x belongs to this interval. Therefore, I can conclude that function is decreasing in the interval for all real numbers except minus 2 and 8. Therefore, I should leave these points minus 2 and 8. Therefore, f is decreasing in the interval. F is decreasing in the interval. I should leave the points minus 2 and 8. Leaving those 2 points, everywhere the function is decreasing only. So I should write the interval minus infinity to minus 2 union minus 2 to 8 union 8 to infinity. Correct? Leaving the points minus 2 and 8. Minus infinity to minus 2 union minus 2 to 8 union 8 to infinity. Function decreases in the interval minus infinity to minus 2 union minus 2 to 8 and 8 to infinity. Option B is the answer. Function is decreasing everywhere in the entire real number line, leaving the points minus 2 and 8. So breaking it minus 2 and breaking it 8. Option B is the answer. Question asked on 29th of January, second shift, JEE Main 2024. Move on to the next one. Question number 5. A function g is defined from R to R, be a non-constant twice a differentiable function, satisfying this condition. A real valued function f of x is given like this, half into g of x plus g of 2 minus x. Given g dash of half equal to g dash of 3 by 2, g dash of half is equal to g dash of 3 by 2, and given f of x is equal to half into g of x plus g of 2 minus x, g of x plus g of 2 minus x. Various options are given like this. You have double dash of x equal to 0 for at least 1x in the interval 0 to 2. You have double dash of x equal to 0 for exactly 1x in the interval 0 to 1. This should be option B actually. This is option C and D. Okay. Option A is given. Second derivative is 0 for at least 2 values of x. And second option is second derivative is 0 for exactly 1x in the interval 0 to 1. Option C is you have double dash of x equal to 0 for no x in the interval 0 to 1. The fourth option, f dash of 3 by 2 plus f dash of half equal to 1. So I'll find out f dash of x here. I'll be using the concept of mean value theorem here. Actually, mean value theorem is deleted actually from the NCERT book, but it's better to study for JEE exams. Rolle's theorem and mean value theorem, and also there is intermediate value theorem. Okay, f dash of x is found first. I'll explain what is Rolle's theorem and mean value theorem also for time being. Just listen. Half into derivative of g of x is g dash of x. Derivative of g of 2 minus x, g dash of 2 minus x, derivative of 2 minus x minus 1. So minus g dash of 2 minus x. F dash of x we got like this. F dash of x. So if you find out f dash of 1, no, f dash of 1 is going to be equal to 0. Note that f dash of 1 equal to 0. F dash of 1 is equal to how much? Half into g dash of 1 minus g dash of 2 minus 1. G dash of 1 minus g dash of 1 is 0. Half into 0 is 0. Next we find out because they given g dash of half and g dash of 3 by 2 are equal, I'll find out f dash of half. What is f dash of half? F dash of half is equal to half into g dash of 1 by 2 minus g dash of 2 minus half. 2 minus half is 3 by 2. Correct? G dash of half is same as g dash of 3 by 2. So the difference of these two will be 0. This and this are equal according to this, using this. So this is also equal to 0. And also you see f dash of 3 by 2 you find out. F dash of 3 by 2 will be equal to what? Half into g dash of 3 by 2. Putting x equal to 3 by 2. Putting x equal to 3 by 2. This will be g dash of 2 minus 3 by 2 is half, correct? So g dash of 3 by 2 is equal to g dash of half. So this difference is going to be equal to 0, correct? So note that f dash of 1 is 0, f dash of half is 0, f dash of 3 by 2 is 0 using this condition, and g dash of 1 minus g dash of 1 is 0, correct? So this much observation is there. I can apply Lagrange's mean value theorem. There are two mean value theorems actually. One is called Cauchy's mean value theorem. Another one is Lagrange's mean value theorem. I am applying Lagrange's mean value theorem. Lagrange's mean value theorem says that the function f defined from closed interval ab to r should be continuous in the closed interval ab and differentiable in the open interval ab, and you can find a point C. I am using not Lagrange's, sorry. I am using Rolle's theorem here. I am using Rolle's theorem for this problem. Function f from ab to r be continuous in the closed interval AB, differentiable in the open interval AB, at f of a equal to f of b, there exists at least one point in the interval AB such that derivative vanishes. Okay. In short, I'll tell you the function should be continuous in the closed interval, differentiable in the open interval, and f of a should be equal to f of b. Then f dash of c equal to 0 for at least one point in the interval AB. Okay. The function is, of course, they told it is a twice a differentiable function. We know every differentiable function is continuous. So it is obviously continuous. It is differentiable. So f dash of 1 equal to f dash of half means if f of a equal to f of b, then f dash of c will be 0 for at least one c in the interval AB. Rolle's theorem says if f is continuous and differentiable, okay, with f of a equal to f of b, f of a equal to f of b is given, then f dash of c equal to 0, f dash of c equal to 0 for at least one c in the interval AB. For at least one c which belongs to the interval AB. Okay, must know this. This is Rolle's theorem. F should be continuous in the closed interval, differentiable in the open interval, f of a equal to f of b, three conditions should be satisfied, then derivative vanishes for at least one point in that interval AB. Here note that function is differentiable and it is continuous already, and note that f dash of half is equal to 0, f dash of half is equal to 0, f dash of 1 is equal to 0. There exists at least one c in the interval half to 1 where f double dash becomes 0. If f of a equal to f of b, f dash will be 0. If f dash of a equal to f dash of b, f double dash of c equal to 0. There exists at least one c. There exists at least one c which belongs to the interval half to 1. There exists at least one c in the interval half to 1 where f double dash of c equal to 0. F double dash of c equal to 0. There exists at least one c in the interval half to 1 where second derivative is going to vanish. Also note that f dash of 1 is 0. Using this, 1 is 0, f dash of 1 is 0, f dash of 3 by 2 is 0. Also, I can write f dash of 1 is equal to 0, f dash of 3 by 2 is equal to 0. There exists at least one c, there exists at least one point, I'll write one point, I'll name the point as d here, okay, which belongs to the interval 1 to 3 by 2, 1 to 3 by 2, where second derivative vanishes, f double dash of d equal to 0. There exists at least one point in this interval because f dash of 1 equal to f dash of 3 by 2. At the end points, the function values are same, derivative vanishes. At the end points, f dash values are equal, so second derivative will become 0. Second derivative vanishes for at least one point in this. Second derivative vanishes for at least one point in this. From this, I can conclude that second derivative can become 0 at least twice in the interval 0 to 1, in the interval 0 to 2, correct? For at least two values of x in the interval 0 to 2. Option A is the answer. Okay? Second derivative will become 0 for at least two values of x in the interval 0 to 2. One value of c, there exists at least one number in this interval where second derivative becomes 0. There exists at least one number in this interval where second derivative vanishes. So overall, I can conclude that second derivative can become 0 for at least two values, at least one value there, at least one value here. So at least minimum two values will be there where second derivative vanishes in the interval 0 to 2, correct? Half, 1 and 3 by 2 lie in the interval 0 to 2. So I can conclude that. Option B can't be the answer. F double dash equal to 0 for exactly one value of x in the interval 0 to 1 is not true. At least one value is true, but exactly one is not true. Okay, there can exist at least one value, means it can have one value or more than one value. So that is the important thing. The third option is also not possible. F double dash of x equal to 0 for no x in the interval 0 to 1. That is not true. At least one value is there. And even this is not satisfied. F dash of 3 by 2 plus f dash of half equal to 1. F dash of 3 by 2, how much we got? 0. F dash of half, how much? 0. Both are 0. 0 plus 0 is 0. It's not 1, correct? Option D also doesn't satisfy. Option A is the right answer. Okay. This is option B and option C. Okay. Please make a note of this. Question asked on 30th of January, first shift, JEE Main 2024. Move on to the next one. Question number 6 is the last question of this January shift, okay, 2024. Only 6 questions were asked from application of derivatives topic. f of x given like this, you want to find the capital M and small m, the maximum and minimum values of f in the closed interval. This is a question based on absolute maximum, absolute minimum. Okay, so find out the critical points of this function. Find out the critical points where f dash of x becomes 0. Find out the critical points and evaluate the function at the end points and also evaluate the function at the critical point. Compare. The greatest is absolute maximum and the least is absolute minimum. So differentiate this to get the critical point. F of x is given like this. X plus 3 the whole square into x minus 2 the whole cube. Apply product rule and differentiate. F dash of x equal to, first function keep as it is. Derivative of x minus 2 the whole cube is 3 times x minus 2 the whole square into derivative of x minus 2 is 1 plus x minus 2 the whole cube into derivative of x plus 3 the whole square is 2 times x plus 3. Correct, derivative of x plus 3 is 1. Now f dash of x equal to 0 to get the critical point. F dash of x equal to 0. F dash of x equal to 0. Take out common terms. X plus 3 is common. X minus 2 the whole square is common. Correct? X plus 3 into x minus 2 the whole square is common. X plus 3 into x minus 2 the whole square is common, right? What remains? X plus 3 is taken out. X minus 2 the whole square is taken out. 3 times x plus 3. Here, x plus 3 is taken out. X minus 2 the whole square is taken out. 2 times x minus 2 remains. Correct? X plus 3 is out. X minus 2 the whole square is out. 2 times x minus 2. X plus 3 is taken out. X minus 2 the whole square taken out. 3 times x plus 3 equal to 0. What we get? One possibility is x plus 3 equal to 0. Another possibility is x minus 2 equal to 0. Here 3x plus 2x, 5x, 3 into 3, 9, 2 into minus 2, minus 4, 9 minus 4, 5 equal to 0. This gives x equal to minus 1. Correct? 3x plus 2x, 5x, 3 into 3, 9 minus 4, 5. X equal to, here I get x equal to minus 3. Here I'll get x equal to 2. So there are 3 critical points here. Evaluate the function at the critical points. Evaluate the function at the end points. Greatest is absolute maximum. Least is absolute minimum. So find out f of minus 3 now. Find out f of minus 3. F of minus 3 is how much? Putting x equal to minus 3 here. Minus 3 plus 3, 0. 0 and anything is 0 here. F of minus 3 is 0. Find out f of 2. F of 2. Put x equal to 2 minus 2, 0. 0 into finite number, 0. F of 2 is 0. F of minus 1. Find out f of minus 1. Put x equal to minus 1 there. Minus 1 plus 3 the whole square into minus 1 minus 2 the whole cube. Put x equal to minus 1. Minus 1 plus 3 the whole square. Minus 1 minus 2 whole cube. Minus 1 plus 3 is 2. 2 square is 4. Minus 1 minus 2 minus 3. Minus 3 cube minus 27. This is minus 108. Correct? Putting x equal to minus 1. Minus 1 plus 3. 2. 2 square is 4. Minus 1 minus 2. Minus 3 cube minus 27. Minus 27 into 4. Minus 108. Critical points over. Now evaluate the function at the end points. Because maximum or minimum value occurs either at the end points or at the critical points. We know this. So using the end points of the interval. F of minus 4 and f of 4. F of minus 4. Put x equal to minus 4 there. Minus 4 plus 3 the whole square into minus 4 minus 2 the whole cube. Putting x equal to minus 4 in this. Minus 4 plus 3 is minus 1. Minus 1 square is 1. Correct? Minus 4 minus 2 is minus 6. Minus 6 cube is minus 216. So 1 into minus 216 is minus 216. Lastly, we want f of 4, correct? F of 4 we find out. All these things are board exam level questions, not a difficult question at all. Many questions will be there NCERT level only, but you have to practice well. PYQs is the most important thing. You have to practice. If you're preparing for January shift 2026, writing JEE exams, PYQs is a must thing. You have to study PYQs first. That's the round level 1 kind of, the round 1 revision type. Round 1 means you study all the formulas. Synopsis part should be very strong of each and every chapter. Formulas, results, everything you must know, and also you must know the PYQs. You should solve the PYQs first. Then only it's possible to solve the problems in the exam. You'll get hold of the subject with solving PYQs. Okay, because many times similar type of questions do repeat. 50% of the questions will be same. So same type of questions will be asked from the past year questions only. So it's better if you practice PYQs, you'll get the idea what kind of questions will be asked in the exam. And 50% of the questions or more than 50% of the questions definitely is going to repeat. Concept wise I'm telling, not the numbers or the functions. Numbers of the functions will be changed, but concept will be repeated. Same concept will be repeated. F of 4 you find out. Put x equal to 4. 4 plus 3 the whole square. 4 plus 3 the whole square into 4 minus 2 the whole cube. Putting x equal to 4. 4 plus 3 is 7. 7 square is 49. 4 minus 2 is 2. 2 cube is 8. 8 into 9 is 72. 7 carry. 8 into 4 is 32 plus 7, 392. So if you compare these values, here I am getting 0, 0, minus 108, minus 216 and 392. Greatest among them is 392. Greatest is capital M. Capital M is the maximum value. And the least is minimum value, which is minus 216 here. This is the minimum value, correct? Minimum value is minus 216 and maximum value is capital M, which is 392. Want to find capital M minus small m. Capital M minus small m. Capital M is 392 minus small m is minus 216. This is 392 minus of minus plus 216, which simplifies to 608. 608 is answer. Option C. Question asked on 30th of January, second shift, JEE Main 2024. Hope it's clear. Simple questions are asked on this topic from this 2024 January. This is the fifth question. Fourth question we had on increasing and decreasing function, and here on more local maxima and local minima. Here also we had on increasing and decreasing function, and this is also on increasing and decreasing function. Totally we had 3 questions on increasing and decreasing, maxima, minima, 2 questions, and 1 miscellaneous type of question we had where multi-concept was used, correct? Various questions we have solved. Okay, with this we completed all the questions of 2024 JEE Main application of derivatives of January shift. Many more videos will be uploaded in the coming days. Please do subscribe to my channel, forward to your friends, make the maximum use of this videos, okay, on the sessions. With this I conclude. Thank you.